R is not a programming language like C or Java. It was not created by software engineers for software development. Instead, it was developed by statisticians and data analysts as an interactive environment for data analysis. The interactivity is an indispensable feature in data science because, as you will soon learn, the ability to quickly explore data is a necessity for success in this field. However, like in any other programming language, you can save your work as scripts, which you can easily execute at any moment. These scripts serve as a record of the analysis you performed, a key feature that facilitates reproducible work. Other attractive features of R are the following. R is free and open source, meaning that you can look at the code. It runs across all major platforms, Windows, Mac OS, Unix, Linux. And data objects and scripts can be shared seamlessly across these platforms. There's also a large and growing active community of R users, and as a result, there are numerous resources for learning and asking questions. It's easy for others to contribute add-ons which enable developers to share software implementations of new data science techniques. Interactive data analysis usually occurs on the R console. In the R console, you can execute commands as you type them. There are several ways to gain access to an R console. The most common way is to download and install R and then start it up on your computer. We provide installation instructions in the course dashboard. The console looks something like this. You can see that you have some information about R, which version it is, etc. And then towards the bottom, you see a greater than sign and a cursor. That is where you type your commands. When you type an expression into the console and hit return, the expression is evaluated. As a very quick and simple example, try using the console to calculate a 15% tip on a meal that costs $19.71. Here's how you do it. You just write the numbers out, hit return, and you get your answer. You should leave a tip of $2.96. One of the great advantages of R over point-and-click analysis software is that you can save your work as scripts. You can edit and save these scripts using a text editor. We highly recommend working on an interactive, integrated development environment, an IDE. This includes editor, R-specific features, and then it has a console where you execute your code. We provide recommendations in the course dashboard. Here's an example of an IDE. You can see a pane where you write your scripts, another one where you have the console, and then other panes with other information, as well as a place for your figures and plots to show up. R has many functions, many tools for you to use. However, the functionality provided by a fresh install of R is only a small fraction of that. We refer to what you get after you first install R as base R. The extra functionality comes from add-ons available from developers. There are currently hundreds of these available from CRAN and many others shared via other repositories such as GitHub. However, because not everybody needs all available functionality, we instead make different components available via packages. R makes it very easy to install packages from within R itself. For example, to install the DS Labs package, which we have created specifically for this course, and we use it to share data sets and share code related to the course, you would type install.packages parentheses and in quotes DS Labs. Then you close the parentheses. Once you hit return, R will automatically install this package, assuming you're connected to the internet. You need to be connected to the internet to download the package and install it. IDEs usually provide a graphical user interface that facilitates package installation. Once the package is installed, we can then load the package into our R session using the library function like this. We type library and in parentheses DS Labs. As you go through this course, you will notice that we load packages without installing them. This is because once you install a package, it remains in place and only needs to be loaded with library. So if you see us loading a package, it's because we have already installed it. Now, if you try to load a package and you get an error, it probably means you need to install it first. The error will say something like error in library DS Labs there's no package called ES Labs.